In this video, we're going to simplify square roots using the multiplication property of square roots. To start, let's talk about what it means to simplify a square root. When we simplify the square root, we want the number inside that radical to be as small as possible. So, as far as determining what it means to simplify in this case, simplifying square roots, let's outline these two things we need. The first is that we want the number inside the radical as small as possible. The second point we want to make is with regard to how we achieve this. So, to make that number smaller, what we're going to have to do is look for perfect square factors. And there will be a relationship between taking that perfect square factor and applying that multiplication property so that that perfect square factor is then just written as an integer and not a number inside the radical. So we achieve this by identifying, and in fact we're going to identify the largest perfect square factor. Any square factor will work to simplify it, but the largest perfect square factor will be the most efficient way to get a radical simplified. So we achieve this by identifying the largest perfect square factor, and applying the multiplication property of square roots. Okay, so let's take the square root of 18. To simplify this, we want to write it as a number with a simpler number inside that radical if possible. So 18, if we think of the factors of 18, we have 1 and 18, we have 2 and 9. And 9 is the largest perfect square factor of 18. So we're going to use that to write this as the square root of 9 times 2. And now we'll apply that multiplication property for square roots, which says that we can turn this into the square root of 9 times the square root of 2. Now, the reason we've done this is that because 9 is a perfect square factor of 18, the square root of 9 now just becomes 3. So the square root of 18 is equivalent to 3 times the square root of 2. And the way that we think of this as simpler is that the number inside that radical is a smaller number. So we've simplified that square root then. Let's do the same thing with the negative square root of 75. Note here that the negative is outside, so this is in essence the opposite of the number, the square root of 75. So 75 has factors 1 and 75. We could do 5 and 15. What we're looking for is the largest perfect square factor. So a quicker way to determine the largest perfect square factor would be to go through all perfect square factors. So things like 100, 81, 64, 49, etc., and determine which one is the largest. So looking at the numbers smaller than 75 that are perfect squares, 64 is not a factor, 49 is not a factor, 36 is not a factor, but 25 is a factor. So we can break this down into the negative square root of 25 times 3. And so now we have the negative square root of 25 times the square root of 3, and that will become the negative 5 times the square root of 3. So the number that is the opposite of the square root of 75 is the same as the opposite of 5 times the square root of 3. Let's look at this last example here, which is the square root of 72. And this one has a number of perfect square factors, and so let's start by identifying the largest perfect square factor. So looking at the factors of 72, if we're checking perfect square factors, smaller than 72, 64 is not a factor, 49 is not a factor, 36 is a factor. So we can turn this into the square root of 36 times 2, and that becomes the square root of 36 times the square root of 2. And then when that's simplified, we get 6 times the square root of 2. Now, in this case, we took the time to go through and make sure that we found the largest perfect square factor. But let's say that we were working on this problem and we didn't find the largest perfect square factor, we only found a perfect square factor. So, we'll do what if, and then I'll look at another scenario here. What if we'd taken the square root of 72 and we had broken it down with a perfect square factor, but say that we chose 4 times 18 instead? Well, that would then become the square root of 4 times the square root of 18. And this is all equivalent. We're going to get 2 times the square root of 18. Now, this is equivalent, but if you go back to example A, we had the square root of 18 broke down further. And so here we have 2 times the square root of 18. And while this is equivalent and simpler, it's not as simplified as possible because the square root of 18 itself can simplify one step further. So if we'd gone that route, we would simply have to then also simplify the square root of 18, which would look like turning this into 2 times the square root of the product of 9 times 2, which then becomes 2 times the square root of 9 times the square root of 2, which is 2 times 3 times the square root of 2, which is now 6 times the square root of 2. So again, looking at that, it's worth the time to go through and find that largest perfect square factor. And those numbers that I was listing off, if we itemize those out, perfect square factors, so I'm just looking at numbers that are perfectly square. So if I square 1, I get 1. If I square 2, I'm going to get 4. If I square 3, I'm going to get 9. If I square 4, I'm going to get 16. If I square 5, I'm going to get 25. If I square 6, I'm going to get 36. If I square 7, I'm going to get 49. If I square 8, I'm going to get 64. If I square 9, I'll have 81. I square 10, I'll get 100. It's helpful to keep these factors in mind as we look at simplifying radicals because it can help shorten our work quite a bit.